Thank you, Desmond, for our introduction.
Thank you to it's your favorite math teacher, Mr. Potts, back with another video. Make sure you go subscribe, and let's get on with the videos.
Don't forget to like.
Don't forget to like and comment.
Like and subscribe.
Let's talk what you should have on your rectangle sheet. So, guys, we should maybe consider that we've got all our information. Guys, you need to... So we've got a rectangle, and it's however you want to label it, but we might say, call this width, you might state that as W, call this length, you might state that as L, and then the area you would have put as length times width. Alright? Now the other thing you might add to it is that if you have a square, it is still length times width. However, we can add these little symbols to suggest all our lengths are the same length. So up here I would put that's the same length as this one, but then I would have double lines, kind of like the parallel. I'm not going to worry about the parallel lines, I'm worried about the lengths. I already know they're rectangles. So the thing with this is, now it's a square, maybe I should label it a square. I can maybe do, well, it is length times width, so area is still length times width, but I can also say that length and width are the same. Therefore, I could say that area is actually the width squared. Width times width.
Yeah, because they're the same thing.
Because if length, I could say length is actually the same as width. So width, I could also say that the area is length squared. Now, that is something that people overlook and they don't get where this squared comes from. But that's what's special about square, is because it is length times width, all right? But when they're the same, if you multiply the same number by itself, that is the same as squaring it. And that's where, do you think that might be where the name squaring comes from?
Maybe.
Maybe. Exactly, so if I was going up to volume, and it's the width times the length times the height of a cuboid, if it's rectangular, as soon as it becomes a cube, all three lengths are the same. Width times width times width, width cubed. Okay, which might be why cubed is called from a cube. Right? Right, so I could consider those, I could add those to my notes. Now, the next one we talked about was triangles. Now, there are a few things we might consider with triangles. So, I would go with my first triangle, the one that we sort of start with, is a right-angled triangle. Okay? And that kind of comes from the fact that you started with a rectangle. Now, it's up to you, you don't need to do this, but we could have started with a rectangle and we've got width and length, and we do length times width, but then we divide it by 2. But then we turn that into a triangle and we say, actually, we're going to call this the base and this as the height. So then it becomes base times height divided by 2. Okay? Or 1/2 times the base times the height. Same as divided by 2. Okay? Now, that's always the same, but what's interesting and what some people get confused on is, what if I change it? It's no longer right angle, it's scaling. And what if the base is not the bottom? What if the base is this length? We ought to be able to show that then the height is actually the... I haven't drawn a very good... I tell you what, I'm going to change this just to make it easy to see. Let's say I make it like this instead. That makes it easier. Then my height is actually,
It's not very
it's not very, but we know that it should be a perpendicular height. So we know specifically that the height is perpendicular to whatever the base is. So if you have a different base, okay, you can have whichever side you like as the base. The base does not have to be on the bottom. So that may be something you can add to your notes. And another thing to consider is sometimes people get confused by the fact that if my triangle is drawn like this, and this one is actually still the base, they get confused about where the height is. But actually, the height, if we can do this, the height is actually still perpendicular to the base. So the height can be measured outside of the triangle. It doesn't need to go through the triangle. Now you might at the moment think, yeah, that's obvious. Sorry, my line's not very good. But, you know, I should look at my screen, not this screen. But anyway, some people get confused that the height line is not drawn through the middle of the triangle. It isn't. It's the measure of from the base to the highest point. So I could even draw it through like that. That would also be the height. Right? So you could add that to your notes. So from the base to however high you would need to go to get to the height of the peak. Highest point perpendicular from the base. Okay? Ava, are you concentrated? Yeah? Okay, so that's something. Yeah. You've got like 4 minutes. Is that impossible? You can if you want, but you've got 4 minutes till the end of the class. You'll have to catch it up. So go if you wish. All right. So we got that. We then did, last lesson, we started talking about parallelograms. Okay, and this is the one we'll finish on today. Parallelogram. So, basically, a parallelogram, hopefully you know, the definition of a parallelogram is two pairs of parallel sides. So technically, a rectangle is a parallelogram. A square is a parallelogram, but they're ones with 90-degree angles. Okay, you can have a parallelogram where all the sides are equal length, and I would denote that with my little sign the same as I did with a square by putting a little, pressed the wrong thing, by putting a little line so they're all the same length, and that has a special name of rhombus. Now, again, you may have done before that actually a parallelogram comes from, again, like a rectangle, two triangles. So that means if we know the base, we then need to know the perpendicular height, not like a rectangle, because a rectangle is like the difference from a right angle triangle. But then we want, so we would go half times the base times the height, but we've got two of them, so we do 2 times half time. So actually that gets rid of that, and it's just base times height, as long as we understand it's the perpendicular height. Okay? Anyone need any clarification, explanation on it? So 2 times the half is 1. That's why we can get rid of it. So half times base times height comes from the fact that I worked it out using the triangle, and then 2 triangles make the parallelogram, so I have 2 of them.
So
The way I think of it is that if you push it back, you can get a rectangle straight away.
Yeah, I quite like when I've got 2 strips of paper that I can actually show you. I need to find these little paper thingies, tabs to show you that work.
Put it back.
And it also proves it has to be the height, not the length of the side, Because if I push it right over, the area becomes 0 because it becomes a straight line, and therefore as it falls over, the area must get smaller and smaller and smaller. So you can't just multiply the two lengths together. Okay? So that's our parallelograms.
Hope you enjoyed the video.
Tomorrow, hope you
Headbutt that
like what people watch and have evidence of. Tomorrow we'll go through the trapezium, so make sure you bring this with you. Okay?
Bye.